As Lawrence Livermore National Laboratory's integrated strategic plan comes into shape over the next 10 years, an essential step in the lab's mission fulfillment means safely demolishing legacy buildings that have played an important role in Livermore's scientific work over the last 70 years. One of those buildings is B280, the Livermore Pool-Type Reactor, or LPTR. Shortly after the Livermore Laboratory opened in 1952, the need for a high-flux reactor to assist with weapons development became apparent, and Albert Kirschbaum, head of the Neutronics Division, began a study of research reactors. With Kirschbaum's guidance, the Atomic Energy Commission awarded an $825,000 construction contract to the Foster Wheeler Corporation in July of 1955. And 15 months later, construction on a unique domed reactor began. Following extensive testing, the Livermore Pool-Type Reactor went critical on December 13, 1957. Like most nuclear reactors, the LPTR's power came from a uranium chain reaction. Fuel elements were placed in a 6-foot thick shield at the bottom of a 23-foot column of water. The water was drawn through the core to carry away 1 megawatt of heat generated by the chain reaction. Unlike commercial reactors designed to generate power, the purpose of the pool-type reactor was to produce as many neutrons as possible to irradiate material samples for experiments. In the 1960s, the LPTR facility was used by Livermore scientists to perform extensive calibration work associated with radiochemical and physical measurements on nuclear explosive tests. In addition to fulfilling its scientific mission, the reactor was a highlight for tours of local high school students and teachers visiting the lab. During the budget-conscious 70s, the reactor was mostly used for trace element measurements and radiation damage studies. Faced with a sharp decline in use, as well as operational costs of $500,000 a year, the reactor was officially shut down and decommissioned in March of 1980. Its fuel rods were removed and sent to Idaho for reprocessing. In 2006, the lab's transition and disposition team initiated oversight of the building, and a formal stewardship program began. In December of 2020, a team from the Department of Energy's Environmental Management, the National Nuclear Security Administration, and the U.S. Army Corps of Engineers performed core drilling, surveying, sampling, and a study of potential demolition impacts. Removal of the reactor's bioshield began in spring 2021, with the completion of the demolition expected later in the year. Over the next few years, the space will be cleared to make way for an adjacent parking structure that will accommodate the lab's growing workforce.